Okay, so we'll start with the lecture. If you can please open your notes and your assignments, we'll go over some of the concept. If you have taken Cisco classes, a lot of this is going to be reviewed for you, but I want to go over some of the concepts so that way when you get to Packet Tracer, it's a lot easier for you to kind of uh, navigate the console. Okay, so as we are approaching the weeks where we have to configure our routers, we are going to use a simulator today that is created by Cisco. I think some of you might be familiar with it. So Packet Tracer. And whether you're using a simulator or if you're using regular router and switch to be able to configure, you need to know how to use your command. Many of the newer devices come with graphical user interface where it would load the prompt and then you would just need to navigate through it to configure. So that means that you can use a mouse to click. And so that requires a little bit more resources. But in some of the older systems, you would see that on the back end, you have a command line interface. It is embedded Linux. So you're going to have similar commands to what you see in Linux systems. Okay. So when we talked about how the router is used to be able to interconnect the networks together, and that's going to be your devices that's going to bring you into the network and out from the network. Now, when you're configuring Cisco devices, you need to know that there are two modes that you're going to operate. So the first, and you have to move into different modes in order to do specific things. So this is important because I always see students struggle with this area, right? So as beginners, you are going to see that you have to go from the user mode into the privilege mode. And until you get to the global configuration mode, you cannot modify anything on the device. So when you first turn the system on, Cisco would have the operating system that is installed on the router by default or the switch. Now, if you don't have the OS, you simply download it from their website, put it on a USB, and use that USB to install it. It doesn't take very long and it's a very small file. So what you see is when you first turn it on, right? In order to connect to it, you have to either use SSH or an application, and later on we're going to use PuTTY. But you're going to open up the command line. It's going to show you the command line. And the first thing you're going to see is you're going to see the arrow, which is it's going to list the information like a router or a switch. It will say switch and an arrow. So that is when you see the user exec mode. And in the user exec mode, you can only use it to show information, existing information. So if I am a technician and I want to go into a switch or a router to look at what kind of information it contains, I simply access this mode and I can do commands like show to be able to display. You cannot modify the setting in the user exec mode. Okay, that's the first level. It's read only. Period. Now, in order to get from this mode to this mode, you have to type in enable or en. And that allows you to move from the user exec mode into a privilege exec mode. So at this point, when you look at your pop-up, you're going to see a hashtag attached to the system name. So if it's a router 1, it's going to say router 1 hashtag. So again, the user exec mode is when we can only view settings where we need to go into the privilege exec mode to be able to access the configuration and modify it. Okay, so at this point so once you get into this area, you're gonna see after I type in enable and press enter, it's gonna take me to the next mode, which is the privilege mode. Now, you have to go from here into the configuration for the global mode. So I still cannot change anything yet until I move into the next step. So it takes 3 steps for you to go in and configure a switch or a router. So what you would do is you would type in config term or config, and it would know that you are modifying or configuring the system. Okay. So when you first turn it on, you won't be able to do anything because a lot of my students, they just try to config at the first level. No, you cannot, right? You have to enable to get into the privilege mode. Once you get there, in order to get to the global configuration mode, you type in config terminal or config and it automatically plugs in the rest for you. But the command that you use is going to be config term to be able to modify your configuration. So at this point, you should see the config in the parentheses. This is when I can put in an IP address. I can put in a service. I can add additional configuration like adding a VLAN and so on. But we have to be able to move from one area to the next. So when you do this, pay attention to where you are and what you're accessing. Same thing with all command line, right? You need to know your path, what you're doing at that level, okay? Now, if you type in exit, it simply take you back to the user exec mode, okay? So once you configure, you can save, and we'll talk about saving in a little bit. And then we can type in exit and it will take us away from our mode. And so when you're in the global mode, that allows you to write the configuration to the RAM of the system, okay? All right, let's go through and answer some questions. So when you're using Cisco router and manage switches, okay, level 2 or higher, which mode is used to configure the devices and how do you access the mode? So like I said, right, when you turn it on, you need to go from the user mode into the privilege mode. So you technically have to type in enable. So the answer is what you see here. The mode that you need to get to is global configuration mode. But the actual step is when you start the system, you have to type enable command to go from user exec mode to privilege mode. Then you would type in config term. You can type in configure terminal command to go into global config mode. So that's the proper steps to actually get there, okay? But the answer for this is that you need to access the global configuration mode in order to configure your system. Okay? So how do I get there? You turn on your switch or device, right? You connect to it, and the terminal would open up. You need to type in enable, okay, to be able to go from a read-only mode into a higher privilege mode, so privileged exec mode. Once you get there, you are going to type the next command and press enter, config term, which takes you into the global configuration mode. So there are 2 steps to actually get here, okay? It doesn't, you can't just turn it on and type in config term. It doesn't work that way. You have to move into one area and then the next area for the router and switch, especially Cisco devices, okay? This is why people have challenges in getting some certification because, you know, it takes a little bit of practice. So you will see that in your packet tracer today, which is a simulator that we're going to use before we start using the regular system. And then that helps you answer number 2, right? In Cisco routers and switches, which mode allows setting changes but cannot be used for configuration? How do you access the mode? So in the privilege exec mode, it allows you to change some settings, right? But you cannot configure, like, let's say that I want my switch to have DHCP, right? I cannot configure DHCP in the privilege mode. I need to get into the global configuration mode, which is the next step, but it allows you to change some settings for the device, like system settings, time, some of the basic setting, but you have to type in enable when you first turn it on to go from the user exec mode into the privilege mode. Okay, any question? Okay, so we talk about the steps. And so when you do it, and if you run into problem, it tells you cannot access it, then think about where you are in the command line interface, right? Which mode you're using and what are you about to do. That's important. Okay, so then what is the point of the user exec mode, right? The first mode that you see when you first turn on your system, it is used to view your settings. So if the settings is out of the box, when you turn it on, you wanted to see what kind of settings does it have. Or if it is an existing device that has been configured by someone, you can go into the user exec mode and you can do like show, certain things, right? You can show the settings and it will be a summary. So you can do a summarized version or you can do more of the details. So we'll talk more about that. Now, keep in mind that commands, in general, these commands will work across most of Cisco devices, okay? Like I mentioned, the newer modern devices don't use CLI. I have some switches back there for business essential, and it only use graphical user interface. So Cisco had moved some of the devices away from the iOS and command line because it's just harder for people to administer. But if you're looking at appliances now in a data center, likely that you're gonna have to do this, right? So then I have to also think about, once I configure, right, I go from different mode, so the user exec mode into the privilege mode and then the global configuration. And when you do that, you see that it shows the parentheses config. This is when you can modify, like I said, right? And then question 4, it says, how do you change the name of your Cisco router to Site1 R1 in command line? So in Cisco, like most Linux systems, you're gonna have the command host name. Host name allows you to find its name. But if you want to set the name first, you need to make sure you access the global configuration mode. Like I said, right, when you turn on the system, you type in enable and config term. But if you're already in it, then you can just type in host name and then the new name for it. So out of the box, the router is going to say router, right? That's what they name it by default. So what we want is we want to be able to identify our router, because in an enterprise network, you're going to have hundreds of routers, sometimes thousands if you're looking at, cloud warehouses, right? Like data center. So what you see is you want to be able to name it like how your company would set up the name. I might say Site1 R1, and I would have another router, Site1 R2, right? Or I might have Site50 R1. So it depends. If I'm at the data center 1, right, like at Wilshire, then I can say Site1, and if it's my first router, I would do a router 1. So logically, we want to name it so that way we can quickly identify if something goes wrong. It's the purpose of being able to trace back your step, right? If there's traffic or delay or there's something going on with your packets coming into your network, you would know which one that you need to reconfigure. So in Cisco command line, first you need to access the global configuration. And to do that, when you first turn it on, you type in enable or EN, and then you are going to go into the configuration mode by typing config turn. Now, in some of the devices, if you just type in config, it would also, assume that you want config terminal. And so once you do that, it's going to turn on the mode for you to configure. Okay. Any question? So when we do this on packet tracer, because it's supposed to simulate like the real thing, you just need to make sure that you look at where you are, like I said, right? Which mode you're using, right? And then from there, you would say, okay, which command do I use to be able to add a new name for my router? Now, if you want a switch name, you just do host name and then switch, whatever, switch one, site one, switch one, right? Keep in mind that different IOSs take different commands. In general, 80% of the command works across, but you would see some switches, even if it has the service, it uses slightly different command. And this is an issue with Cisco with the legacy devices, is that you would see that some commands work for in most models, and then you would have like 2 models down the line that doesn't, the commands became deprecated. So you can't use that same command. So the best advice that I can give you is look at the manual. Okay, I know it's a lot, but you can go on Google, just search up that model and look at the manual. It's all in PDF. You just scroll down or you can do a keyword search and you can find specific command in case you get stuck. Okay, because you're gonna see this in the lab. So I don't care what people tell you, they can say the simulator can train you. Simulator cannot give you thousands of different models for Cisco. When you learn on the job, sometimes you run into problems. This is when you're going to start learning how to fix the problem and be able to understand commands more. But if you practice with the general models that you see in Packet Tracer, you're going to get like 80% of the commands that are usable in most of the devices. So I'm going to tell you now, when you go on a rack, you're going to have a couple models different. Sometimes they don't take the same command, and you just have to, think about how you would be able to navigate that kind of problem by looking up the manual. Okay, that's a common problem. Okay, so we can find this information on our notes, right? It talks about the host name here, an example. So again, we have to be in the configure mode. Now, if you want to get out of that mode, you can go disable. If you do an exit, it takes you out of all the modes, right? So when I do an exit, I simply go from configuration mode all the way to the start, which is not even inside the user exec mode. But if you want to go back into the user exec mode, you would see disable. Now, some appliances doesn't use disable, it uses exit. So like I said, there's some discrepancy between the OSs. But as they move along, they streamline some of that. But in general, you can go back into the read-only mode when you type in disable. Okay? All right. Another thing that we have to pay attention to is how your interfaces are, okay? How they're named, how they're recognized by the system. Because a lot of my students, they just follow the lab instruction. I might write a lab for multiple model. So you're gonna have switch that would have either Ethernet, fast Ethernet, gigabit Ethernet, or serial. This is very old, okay? But you might have something like that. An older system, more of like the close to current modern system, and somewhat of an older system at the top. Now, each of the port, right, when you're looking at the switch, each of the port, it would be referred to the interfaces that it contains. So if I have a 24 port switch, they all might be gigabit Ethernet, right? Or they all might be fast Ethernet. And then sometimes you might have all 24 ports that's gigabit Ethernet, but you have some additional port that is maybe faster or maybe slower. Okay, so pay attention to the interface that your switch contain, because sometimes students just like, oh, I just type in G1/2. Well, that's gigabit Ethernet, but your system doesn't have gigabit Ethernet. It has fast Ethernet by F1. You have to name it a different way. Ultimately, these interfaces give you different transmission speed. Okay, that's very important. Okay, so when you program them, you would say, let's say I want to take port 1 to port 20, and I want to make it into a VLAN. Well, you have to tell it which interfaces that you're grabbing, that you're grouping together for the VLAN. Okay, so fast Ethernet, your throughput is going to be 100 megabit per second. And it uses RJ45 connector, your Ethernet adapter or connector that you use for your cable, and you would plug that in. So it supports up to 100 megabit per second. So when we say up to, you don't always gonna have throughput that's gonna be exactly at 100. Ideally, we want all of the ports to be talking as fast as possible so we have performance. But you do see that, when you have cables together, they have signal leak. And then when you have concentration of traffic into an appliance, you have congestion, and that causes latency. Okay, so you're going to go between 10 to 100 megabit per second for fast Ethernet. Now, most of the devices now uses at least gigabit Ethernet. And when you're looking at AI data center now, they're at terabyte per second. So that's incredibly fast. So it uses different processor inside the actual switch and router. So, but in general, you're going to see gigabit Ethernet. So it usually indicated GI or G, and then the port number, and you have to put up 1,000 megabit per second or up to it. So we're gonna go 10, 100, up to 1,000. So you can actually make certain port as fast as possible, and then you can dice down some of the ports to make it less. Remember, we talk about priority. It's kind of like how you have the fast lane that people pay for, right? When they go on the freeway so they can drive faster and there's less traffic. So some traffic is prioritized, and we can port it over for the fastest speed, and then some of the traffic might not need as fast, so we can actually control the ports also. Okay. All right. Any question? Okay, so here that should be the answer for number 5. So what is the speed difference between Ethernet, fast Ethernet, and gigabit Ethernet? So Ethernet is going to transfer between 0 to 10 megabit per second. Fast Ethernet is going to transfer between 0 to 100 megabit per second. So even if you're on fast Ethernet, sometimes you are as slow as Ethernet, right? Depending on, there's a lot of factor that plays into congestion or latency on a network. And then gigabit Ethernet transfer between 0 to 1,000 megabit per second. So when you get into the field now, right, if you work in the data center that is used for AI, you are going to see 0 to 1 terabyte per second, 1 terabyte bit per second. That uses different processor, like I said. But in general networks, most of your communication devices are at these 2 levels, right? So if they are slower, they can upgrade the switches to make it faster. It's kind of like, how we can add more lanes or make the lane smoother and better to be able to have more cars driving on that lane. So we can use devices that can pass through quicker. We can use faster cable, right? And the newer devices, ultimately, you would see that it has higher processor, higher RAM. So your hardware resources is always going to be in parallel with what you see for performance. Any question? Sorry, I tried to get the back screen to work, but I think they just attach it to the second monitor from the PC, so it's not fully displaying either or. So I'll have TSS look at it again to make sure that the switch up here. Okay, so you kind of understand there are different interfaces for each of the ports in the front or sometime. So I put the comment for many of you who did the diagram, the topology during the first week, right? You trying to connect many devices to the router. Unlike your home router, your regular router doesn't have that many ports. It usually have like a couple of ports in and out, and that's it. It's a transit system, so what you see is that it might be faster than gigabit Ethernet. You're looking at, you know, so some router now, right, is equipped with fiber. The majority of the older routers, you would see that it would use Ethernet adapters. So you can connect it with Ethernet cables. But the switches in general, they're gonna have a lot of these ports in the front. Okay. Okay. So that was what we saw from page 1 of our notes. All right, so this is what I was mentioning before. So when you're using, when you're looking at specific ports like Ethernet ports, right? You would usually tell the system, once you're in the configuration mode, you can use interface and then the ID. Now, you can obtain the ID information in the user exec mode when you can do show interface, right? Show in Linux and in embedded Linux or iOS, like Cisco iOS, simply is a way that we can display the table or the list, okay? So I can do a show interface in the user exec mode, and I would know all my ports. It's gonna give you, so if your switch have 24 ports, it's gonna give you, right? For example, if it's fast Ethernet, it's gonna say F0/1, right? F0, F1/1, and so on. So it's gonna increment all the way to F24. Okay, that means that we're gonna go for fast Ethernet fast Ethernet port. The first port is always gonna be 0, right? I'm sorry, and it's gonna go all the way to 23. Okay. So we can do a show interface, and then when we want to program that interface, we have to get to the global mode, and we can type in the interface name. So for example, I want to set an IP address for that port, right? I would say interface F0/0. And then the next thing that I need is I need to do a config IF where I can type in the IP address. Okay. And just like in your Debian Linux, you type in IP address and then follow it with your IP address value, and you would have your IP address stored. Any question? So we have to, if you just type in interface without the ID, it's gonna throw an error. It's gonna say, which interface are you talking about, right? And then when you access that interface, that's basically a physical port, then you can go in and you can do something with it. For example, I want to put in an IP address for it. I can type in IP address and then put the number for my IP address. And then I can set the speed. Remember what I said? We can make it the maximum speed, or we can slow it down. So if you put the numerical value here, it allows you to control how fast that port transmits. So if I say speed 1000, that's 1000 megabit per second. Or I can say speed 100, that gives me 100 megabit per second. So some ports get priority in the traffic and they would get the maximum speed, kind of like your fast track lane on the 91. Or you can get some port that you want to slow it down and reserve your bandwidth for other ports that have priority. Okay, so you can type in the speed and the value. Okay. So let's look at some of the commands so that way we would know. Okay. Provide the commands to configure the following information on a router. First, we want to put in an IP address with the subnet mask, right? The given IP is 214.6.0.1, always a .1 because it's a router. And then we want to add a description, and we want to give it a speed, and we want it full duplex. So it sends and receives concurrently. And we want to activate that interface. So you would start with, again, right? We have to get to the configuration mode. That's what we talked about in the first three questions. So once you're in the configuration mode, you're gonna type in IP space address and then the given address and its subnet mask. So this is a class C default address. Then after that, we're gonna add the description because sometimes it's helpful when you troubleshoot if you have some information about the system. So you just type in description as a command and then add the string that's given to you is district LAN. Then we're gonna add the speed to give it the maximum speed. So we would say speed 1000, that's 1000 megabit per second. And as you do this, you press enter, right? Just like how you do it in Linux terminal. So once it records the speed, so the terminal, if it's successful, it's not going to confirm, right? It won't say, oh, successful speed set. No, right? It'll just do the next pop-up, and then you would say full duplex for your transmission. And then the magic term, but this doesn't always work with all models. You type no shutdown, okay, to store that information onto RAM. Now, when you see this, you would see when you use the actual device, you would see sometimes you can't use no shutdown for this. You have to find another way to save the information. So after this, I would say disable to get out of the write mode or the global configuration mode and then move back into read-only mode, which is the user exec, right? So to get out of your configuration mode, you would type disable and it brings you back to the beginning. Okay, so all of these information came from this section on page 2. Okay, so I want to kind of show you some additional example on how you would put in some additional command for certain services. We talked about DHCP. We configure a Windows server system for DHCP, but you can use network appliances for DHCP. Case an example, your home router is a DHCP out of the box. So you can use like a switch to be able to enable your DHCP. So this is how we would configure. Now, unlike the Ethernet port that we talked about, let's say you have a serial port. Okay. So what cable is connected to a serial port? You know? So Cisco uses one of those D pins. It looks like the VGA on the on your computer. Let's see if I have some of this. Show you. But the serial connection, it looks like a VGA connection. Oh, somewhere. Okay, but anyway, so it has these two screws on the side. They look like it's like a shaped D, right? Those are for serial. That's kind of like an older Cisco device. But you would do the same thing. So instead of fast Ethernet or Ethernet, you would say interface, that's the port. And then you would say serial, and this is the first serial port, so 0/0, right? So once you access that interface, then you can say IP address DHCP. So that means that we are going to obtain an IP address from a DHCP server. Now that server can be another switch, it can be a Windows server, right? Whatever that you would use to distribute your IP addresses. When do I actually do this? I do this for people who are connecting to that port to obtain an IP address on my network. It could be that they are remote in, so I can set up some remote services with that, which is what we see with point to point right here. Okay. Now, if you want to have like encapsulation protocol, you simply use an encapsulation command, but you have to use the service that's represented for that, right? So HDLC and point to point. So you would do an HDLC that way. So HDLC, it means high data link control protocol. This is specifically for Cisco. It was made for Cisco. It's used to connect one Cisco device to another device. So if I have a switch connecting to a switch with a serial cable, which is slow, right? Then I have to use HDLC. And the reason why we want to encapsulate it so that way it would be able to convert that data when it carries from one device to the next device. Okay. Now, another protocol that you can use that is not Cisco based, so a switch would come with two options. One is for Cisco only devices. Two is for Cisco to other devices that is not Cisco, which is point to point. Point to point, so Triple P has been around for a long, long time, right? But this allows you to connect to devices that are not Cisco type. And so this would allow you to authenticate and we would be able to have it communicated. Now, serial is like collecting water one drop at a time in a bucket. It's taking a long time to fill up. Versus if you have other type of connection. So when you're looking at a very much older device, you can't use anything else except for serial. So just know that if everything funnel back to a serial connection, right, on your rack, on your backbone, you are gonna be crawling slow, leaving the network and coming in. Okay. So this is what we face quite a bit for a long time. So when you upgrade the network, you have to upgrade the devices that have better, faster interfaces and use faster cable. Okay, you can also set your clock rate. This allows your data to link with the equipment. So we can set up your clock rate and this is the value. So 64,000, that's gonna be for, it mainly is the clock that's gonna be syncing with the processor of the device. So we want to be able to set everything up and then ultimately before you get out of that mode, you type no shutdown and it's gonna store that information into your settings. Okay. Okay. So one of the things I want to tell you, and you're going to see this when you do your lab, right, is you can store settings into startup configuration. So when I do no shutdown, it's going to take my setting, it's going to apply it. But I want to write it back into the actual ROM that it's going to use when it boots. Okay. Most of your network devices don't restart, right? Because we don't shut it down. So it saves the information into RAM, but you want it to also store it into the startup option. For example, I wanted to have DHCP enable when it turns on. So you need to do a full command, copy running config, startup config, like that. Okay. And so what it does is it's going to take your settings and it's going to store it into a different location of memory. So that way it would then be able to retrieve it when it boots. Okay. Any question regarding some of these commands? Okay, so let's go through and answer some additional questions. Number 7. Which serial link encapsulation protocol is used to connect Cisco device to another using back-to-back serial link? And if you're using Cisco devices to Cisco device, you use I have a T there. I don't know why I have a T there. High data link control protocol, so your HDLC. But if you're using a Cisco device to a non-Cisco device, you use PPP, point-to-point protocol, okay? Question 8, what command is used to enable the interface after the configuration is modified? So you want to apply the settings that you have changed, you type no shutdown. And then we want to store the setting that we modify into the ROM to be able to, it actually uses EEPROM. It would then refer to it every time that it boots or every time it runs. So we want to say copy running config, right? That's the configuration that you have applied to the startup config. So copy running config, startup config. If you are previewing the lab early in this class, you don't have to install Packet Tracer on the classroom computer. They already did that for you. But if you're using your laptop or your home computer to complete the lab, you will need to install Packet Tracer. And the way that you get Packet Tracers, you have to create an account. We pay for your Cisco Academy already through grant money. So that's going to go for the next year or two. So you should be able to use your RCCD account. Do not use your personal account. Use your RCCD account to create a login for Cisco. If you do the skills only academy, that is like free for all, but you still have to create a login. And that one you can use your personal Yahoo or Google or Outlook account. But for today's lab, you have to use the RCCD account. Even the free one, if you have an EDU account, they should be able to give that to you for free. Okay. All right. So let's talk about zones. So segmenting is super important in networking and cybersecurity. The reason why is when we are logically separating different areas in our network, we can control how the data flow into the network and from that particular network. We can also physically segment the network by, so when you look at the data center, it's not really in different location as far as like switches and routers, okay? They're on the same racks, but logically we separate them. It could be on one switch and you can have 2 separate virtual lanes, or 3 or 4, right? But in some cases, geographically, you can actually separate these things. Ideally, we don't have to revert to that, but so you are sitting in a private lane, right? The school local area network is an internal network. When you're at home, you are in your own personal area network. So a private LAN is then going to be attached to a router, and that router connects to your service provider or another network. Then you have wireless. Wireless should be controlled with security, right? It is connecting to the LAN. When you did your topology, I mentioned that you should attach your access point to a switch, right? So the way we treat that is it is a separate entity inside our private network, even though it's part of our private network, but it is completely wireless there, right? So your access point needs to be connected to a switch, and through that access point, you would have many clients that's using wireless, okay? And then you have the wireless, yes. Ideally, this should be a completely separate zone from your regular wireless, okay? So if I own a hotel, for example, right? I'm gonna have a wireless network that is for my employees and all the systems that I use. You know, the door key, all of these things that they use that are wireless. Then I would have a segregated another access point specifically for the guest. So I would attach another AP, right? For the hotel guest that comes in and that's on the switch. Okay. And what you can do is you can use IP to segment it. You can use firewall to be able to control it, but you should be separating them and do not put them on the same AP because there's opportunity for someone to get into your private network through your wireless network. And it is a common thing. Okay. Then you have a DMZ, right? So when we look at the demilitarized zone, that is all the systems that are facing the public. So what server faces the public? Your web server, right? That has a lot of web traffic. Okay. So with web server, you know that there's DNS following. Okay. So if I have mybusiness.com, right? Maybe I'm selling things online. Then if I'm an e-commerce, I have a lot of traffic into my web server. So that means that the traffic is coming into the router for that side. And then from that router, it's going to bring the traffic to the web server. So DMZ is its own entity that is segregated onto the network. And this should be a separate component from your private LAN. Okay, so here's your private LAN, here's DMZ, and in between, we're gonna put firewall. Okay. And we're gonna route everything into the private LAN with different IP addresses. So it uses, right, router and its own firewall. And then we're gonna route the traffic that is public facing into that particular. So now, do we attach this into the private LAN? Yes, you can. You just need to make sure that there's security in between. So in militarized zone, when you logically look at it, it is separate areas of your network, but ultimately, if you're looking at in a server room or a data center, everything is all there in one room. Okay. So I'm hosting web on one rack, right? And lower on that rack, I might be doing other things, like I might have like DHCP server and other things, but in between, you're just gonna have to have attached appliance support. Okay, let's answer those questions. Okay, so we see the answer from the note pages. So these are only a few types, right? So when you're looking at an infrastructure, ultimately you have components that really represents the area of different part of the network this way. So your DMZ, demilitarized zone. So you see mail server also exists there too, sometimes, right? So anything that has public access, you have some databases, but not a lot of private information on that database, like, you know, user account information. And then from there, you can bring the data into other databases. So your simple mail transfer protocol, this is your mail server, your DNS, your web server. Okay. So wireless should be subdivided, like I mentioned, into different separate zones. Okay. And you can also, it's better to do group policy rules that you can apply to your wireless or your private network or your DMZ. So I can have rules such as nobody can attach to my private wireless network without having antivirus or security software. And so when you're trying to attach to, you know, your SSID, when you click on it, you know how RCCD prompt you with, you know, term of use and you have to click accept, right? That means that your information that you use on their wireless network is public and they're not responsible if something happens to your information, right? But in some wireless network, it is it needs more security, you require that they have a health check for their system. And you can set it up with zone control. Okay, let's move 10 down. Or maybe 11 up. Okay, so let's talk about some of the additional protocol, right? But I want to touch on switch a little bit. So you have level 1 and level 2 switch, which is just basically passing the data into the specific system once it arrives into the network, right? So it needs to learn the MAC address. And the MAC address, and we talked about this in the last session, all the connected system to that switch, if I have a 24 port switch, all the 24 systems that are connecting to those 24 ports, their connection is stored on the MAC table, right? We saw ARP last time. The connection information, it shows the MAC address. So the switch table can contain which system and its MAC address, okay, and which port. So when you look at the switch table that's different than the router table, you're going to see a list of all the connected system to it, right? Anything that's connecting to that switch, if there's another switch, you're going to see that too, okay? Now it can be used to filter the data to the port, right? You hear firewall filtering all the time, but you can also use the switch, but the switch itself actually filter out only specific system is receiving the data as intended. So if I have system A with this MAC address, it's sending, right? It's going to have the information for the sending system to system B that has its own MAC address. And the associated MAC address for the system for the connection is then stored. So that way it's not sending to other system like system C or D or F, right? So it is specific to that system because it has the MAC address. It's kind of like I send you a package, it's only for you, so they don't deliver it to the house down the street. It's gonna go to your house, okay? So the switch makes sure that it gets to that right MAC address. Okay. So the next question pertains to spanning tree protocol, your STP. This allows the switch to reduce loops in the network. And so this is also known as a loop avoidance technique. And so what it does is it take the ports and it puts it into a blocking state. So when the link goes down, it prevents it from just looping back. So when we say loop, it's just going to come back to itself, or it's just keeping getting returned, right? So what you want is you want to make sure that it blocks it so that way it can forward it to the right area. It's kind of like how if you drive down the street and there's construction zones and you can't go forward, so you have to keep returning home, but you can't get out of that neighborhood. You just keep coming back, and that's a loop. And when you have loops, what happens is you get a bunch of error and you don't receive your data. So you would have maybe network disruption or a slowdown in communication. So what it does is this particular protocol makes sure it puts it into a blocking state, so that way it creates like a detour for you to be able to go forward. So it would then send it forward again, so that way you can get your data from system A to system B. Because if we don't do that, our data will never get there. Okay, so at the frame level, we would have sometimes floods. So when it does a flood, it's going to broadcast all the information because it doesn't know where it's supposed to go. It's kind of like the post mail delivery person stands down the street with a loudspeaker and says, I have a package. I don't know who this belongs to. Come and claim it. Like, who's going to know, right? So when it floods, it's going to take that frame right? It doesn't know where it's supposed to go to, so it's just gonna send it to everybody. And when you have this, you have network bandwidth reduction. So you don't want a lot of flooding because now everybody receives that frame. Everybody receives your information. You don't want that, right? It does the forwarding and it does the filtering as we talked about. So the forward is to make sure that it goes to the right port with the right MAC address for that system. Okay. So for 11 is ask you how, explain how STP is used in loop avoidance. It places the ports involved the loop into a blocking state. That's the first step. Second, if it goes down, it's going to then detect that it goes down and it changes the second and make sure that there's a secondary pathway for forwarding. So 3 actions that the switch actually take. 1, it's going to flood all ports, sends everybody the same information. If it doesn't know who's supposed to receive that or which MAC address that is. So can someone cause your system to flood? Sure. Right? They would generate arbitrary frame to be able to send that. And if your system doesn't know who's supposed to receive that, it's going to say, I don't know who this is, right? Here's the information for everybody to know. So you would have floods. And then second, it can forward the frame to the known system based on the switch table, which contains the MAC address and the port number. It can also filter, so it's going to refer again to the switch table and making sure that it gets to the right destination. The hard part about networking, I think, is that you have a lot of different appliances. So you are not just, you know, your PC, your client PC, your server that you have to know how to configure and troubleshoot. You also have to troubleshoot communication devices as well, right? But once you understand, like, you know, the purpose of the certain action on each of the device, it's a lot easier to kind of narrow down the issue of the device. Yeah. Yeah, private tends to be referred or assumed that it's wired. Yeah, like an Ethernet type of environment. Or if you have fiber. But yeah. And then you have like the sub part of the LAN, which is gonna be your wireless. Okay. I'm gonna move 11 and 12 down to the next page so we can talk about 13. So, sorry. Let's show you where that is on. Okay, so here it gives you a little bit of summary of the STP compared to RSTP, and we're going to touch on that right now. So you saw spanning tree protocol, your STP, and then Cisco later released the rapid spanning tree protocol, your RSTP. So STP uses an algorithm to know about which port, right, that has a loop issue, and it's going to do the blocking state. So it uses a different standard sub-value. So it's IEEE 802.1D. And it takes 52 seconds to change the port from a blocking state into a forwarding state. So you do have a little bit of a time requirement. when this takes effect. And there are 4 states. So there's blocking, listening, learning, and forwarding. I know you guys saw this when you look at your get net connection command in PowerShell last time. You saw how it says listening, right? Some of you, I know my class did it on Friday, and they keep trying to search for established connection, right? So sometimes you would see listen or listening, right? So that just means that it's there, it's available, it's ready to receive, right? Now, when you go from blocking into forwarding, you do have about 52 seconds in between for it to change the state. But in order to have the new information updated, it's going to learn. So that would be an actual state that it would go through. So when you look at the switch table, you would see that it's going to list one of these 4 or all 4 if it's doing all 4, right? So usually you're going to see either blocking or forwarding. So it's going to change from blocking into forwarding. Now your RSTP, your rapid spanning tree, this is an 802.1W standard. It is an improvement of STP. There are only 3 states: blocking, listening, and forwarding. They got rid of the learning because that just takes additional processing and time. So there are only 3 states. It uses an alternative port as a backup link. So instead of taking one port, like port 1, and changing it, it creates a secondary port, and then it's going to pass it into that secondary port. So that way it's quicker and we don't lose a lot of time with rapid, hence the name, right? So when the port goes down, it activates an alternative port, and it's going to use the voting process from the STP to be able to make sure that it changes into a forwarding. Okay, so you have less time ultimately with RSTP, and keep in mind that, you know, this is the common protocol that you see with Cisco switches. Okay, so in the past, I had you look up a managed switch and an unmanaged switch, right? And a managed switch, it is configurable. We can go in and we can set up our switches to be used a certain way. So it has configuration capability, whereas unmanaged switch, you just plug the devices in and it's just gonna pass your traffic back and forth. It will not be able to have any kind of settings. You don't manually set it, right? Out of the box, you use it as it is for the unmanaged switch. The managed switch allows you to do more to it. You can add services, right, like STP or RSTP. You can, if it is a layer 4 or higher switches, you can create VLANs in it. So ultimately, in a network environment, you're going to see a lot of the switches are managed switch. The unmanaged switches are the switches that are connecting to the endpoint devices, right? Like maybe the switches that are connecting to your desktop right now. But those switches are ultimately going to connect to the larger managed switches where they can be controlled, okay? In my opinion, if you can have mostly managed switch, you can control a lot of the resources, but they are pricey, right? 5 times, 10 times more than what you see with the regular unmanaged. Okay, any question? So we are going to have dedicated units specifically for router and specifically for switch. This is kind of like an overview of what's to come. Okay. Okay, so managed and unmanaged switch, you can find that on page 3. And then it also talks about port bonding or LACP. This allows you to link multiple ports together so that way you can combine the bandwidth. So let's talk about that. Let's say that I have one port that is 10 megabit per second. I have another port that's 10 megabit per second. And I want to create like faster, right? By combining all of these ports. So I can combine 10 ports together, right? That's going to give me 10 times more than what I have for each of the port connection. And this is what we know as port bonding. And so you can have up to 16 ports in a 48 port switch to be combined. And what, so you have to configure LACP in order to do that. Okay, so you can bond the ports. Okay, so the next page it touches a little bit more on the VLAN. Okay, so the example here, we're going to aggregate port 11 and 12, right, for the Ethernet, gigabit Ethernet, and we are going to make this into a VLAN 2 and assign it to Ether channel 5. So the way that we program this into the switch, first you turn it on, then you enable to go into the privilege mode, then you type configure terminal or config term, so that way you can get to the global mode or global config mode. Then you are going to type interface because these are for your physical ports. And because we are using 11 and 12 as what the example states, you're going to do a range because it's multiple port and the type of port. So it is a gigabit Ethernet. So you make sure that you put in the type of port that you're using and then the value. So this is the ID right here. Okay. So if I do 10 to 12, 0/10-12, right? Or 8 to 12, 0/8 to 12. Okay. Now the switch port is for certain version of iOS, right? So this would work with certain model, but switch port in general allows you to be able to configure things like VLAN. So you have to do a switch port mode access. And then once you have the mode access, so basically you're saying, I'm accessing, right, the port for the switch port access, and we're going to do now VLAN 2. Now, if you didn't create a VLAN 2, it's going to automatically create it here, okay? And then I'm going to set the channel and activate it. Okay. So now for 15, it says provide the commands to configure VLAN 2 with an IP address 12.0.0.3 on the switch. Okay. Same steps, that's what we talked about. First, you're going to type in enable when you turn it on. Once you are in the privilege mode, you're going to go into the global config mode by typing in config term. Once you can get access to the configuration, you would type in interface because that's going to be your port, right? So interface VLAN 2 because that's what we want. Okay. And then in your path, it's going to show parentheses VLAN 2, and then you type in IP address and subnet mask. The reason why we're using 255.0.0.0 is because this is a class A by default. And then we type no shutdown and exit. Some of them you just type disable, but you can do exit. So that will take you from configuration mode into read only. Now, if I want to put this into the startup, like what we talked about, so then you would have to do running config, right? To startup config. So. So this, you can refer to the second example there. You can follow that pretty closely. You can use that one and then replace the information for your answer. So these are each of the command you type in, right? Okay, so how do I configure a default gateway on my router? Not all routers are default gateway. Most of the routers are configured as default gateway. So it's really simple. You would do enable config terminal to get into the configuration, and then you type IP, default gateway, and the IP address for it. Okay, again, like I said, usually router or default gateway is a .1 at the end for the host. Okay, so that would help us with answering number 16. What is the command to configure the default gateway for IP address 112.0.0.1? Again, you have to get to the configuration mode, and then you just type in IP, default gateway, and the IP address for it. So you're expected to know these commands for not midterm, but your final exam and quizzes. Okay, and also for your certification, especially if you're going for Cisco. RCC does do the Cisco series, like the CIS26A through F or whatever. In my opinion, if you know that you want to be Cisco certified because that's an area you want to get into, then go for the certification. They're pricey and they are in series. They're stackable, right? But you can work in it without Cisco certification. Okay. Now you just have to be good at practicing this and then learning how to work. And you can always use Packet Tracer to practice if you don't have a device. If you are able to find an old Cisco switch or router, you can find them online for cheap, even $20 or less. I've seen some security appliances on Amazon, like the older ones, for like less than $25. Okay, use. So you can find them and you can practice, and that's how you're gonna get better. And that's the only way. I encourage you, because Packet Tracer can only do so much, but if you have some hands-on, it's gonna help you understand why certain things are not working and how you can overcome those things. Okay. Power over the Ethernet is here. So on some switches, it uses PoE. So when you read the description, when you're buying a switch, you might see that it is PoE. So basically, we can receive wattage through the Ethernet cable. So it receives power, because ultimately, Ethernet receives electrical signal, right, to be able to transmit as data. So you're able to receive power through the Ethernet cable. But like voice over IP, it can use one port for power and data. So that way we can save the connectivity and the media, so you don't have to run extra power cable and extra data cable. It can use for both. And then you have PoE plus. I know some of you learned this for A+ certification. This is IEEE 802.3 because it's Ethernet, right? That's gonna always be 0.3, but this is an AT. And the main difference is that you actually have higher wattage. So 25.5 compared to 15.4 watts. It's about 10 watts in difference. And sometimes that makes a huge difference in the device connection. So that will be the answer for 17. The main difference is that power sent over Ethernet is 15.4 watts compared to PoE is 25.5 watts. So you can receive power and data together. Okay, so how do we create a VLAN and name it finance department? 2 steps are going to be the same. The first 2, enable and config term to get into the configuration mode. Then you are going to type in VLAN database. And then we are going to now create a VLAN 4. So some switches, because of limitation, you can only, like, if it's not VLAN equipped, it's gonna come default with 1 VLAN. Okay. If you're using a switch that is layer 4 or higher, you're able to create multiple VLANs. So you would do VLAN. And then the name here is going to be the department that you use it for. So what I can do is I can connect the systems from the finance department onto the ports for these VLANs, right? And then I can set up the ports, like the first 10 ports or the first 5 ports. Okay, so that's what we're gonna do next. So now what I'm gonna do is I'm gonna take port 5 to port 8 and I'm gonna link it to the VLAN 4. So that way those systems that are connecting physically to these ports on the switch is gonna use VLAN 4, and that's for the finance department. And that could be their application server or whatever that you want to use it for. So again, we're gonna do enable, config term, and we're gonna do an interface range. This is a fast Ethernet, port 5 to 8. Then we're gonna do switch port access VLAN, so that way we can tie that into the VLAN. And then we do exit. The reason why once you exit, you now here at this step, you are in the user mode where you can view. So if you want to know for sure that your VLAN's created, when you do a show VLAN, it's gonna list VLAN 4 and F0 5 to 8. If it doesn't list it, then your VLAN didn't stick. So you have to do it again. Okay. So as you make each VLAN, I recommend that you exit out of it, right? And then you can show the VLAN to see if it's applied. If it doesn't, then you don't have the configuration set up accordingly, so it won't work. Any question? So I hope that you use this as notes and preference of reference for your lab today, and the next, when we get to the switch lab, which is in a few weeks, you are going to have to set up your VLANs and you have to show me that you did. All right, leaving this class, I want to make sure that you all know how to do that. At least put that on your resume. Okay. So whenever that you practice on a certain switch model, even in packet tracer starting today, add that to your resume, even if it's older, right? Because when you tell me that you're able to configure switch, a Cisco switch, I might not believe you, right? But if you put, configure a Cisco switch and then the model number or a bunch of model number, I'm like, okay, this person have experience. And so using the switch at my company might be close to what this person has knowledge in, right? So just make a practice of, after you do the lab, the exercises, update the information for your resume so that way you can apply for work. Okay. So a protocol that you can use to create a list of VLAN from one switch and transfer that list to another switch, we can use the VTP or VLAN chunking protocol. Basically, we can make the VLANs list, right? We create a bunch of VLANs, we use that list, and we can transfer it to another switch. This is for convenience purposes, but again, trunking is actually an older technology. It's still being used because you have some older switches still being used. But in the newer technology, you don't need to trunk anymore. However, it is allowing you to apply the same list of VLANs onto other switches, so you don't have to manually set them up again and again. Okay. So how do I use the native VLAN 2? So native VLAN 2 are for some switches that it only have a specific default VLANs created within. So you would do switch port, trunk, native VLAN 2 as a command. This allows you to configure the VLAN 2 that is native, and you would use the trunk command. So again, switch port is the command, and then trunk is what we talked about here, right? And then the type of VLAN that you use. Okay, so configure VLANs, you can start following it from page 4 and going into the next couple of pages. You can name your VLAN anything you want. We already talked about setting up ports for our VLAN, right? And you can do it for multiple VLAN and one switch. You see, I have VLAN 2, VLAN 3, and I use port 2 to 4 for 2 and 9 to 12 for VLAN 3. And then your trunking is 802.1Q. You can read the information here. So, I know that many of you are like, oh, you know, I want to learn about Cisco switches and routers because that's what you see. But a lot of the data center actually use Juniper, right? And others. So you would see that there are many other brands, and they might have similar commands. But like I said, right, if you don't know to start, read a manual, go through it, see how it's set up. You can go to their website, you can find information. But commonly you would see more Juniper being abundantly used. And then there are newer devices as well. Okay. Okay. So we talked about native VLAN, and native VLAN just means that it is a default VLAN, right? That is created for that switch. So in some switches, you cannot add additional VLAN. You can only use the native VLAN, and that's what you have to trunk. So in this one, I turn on port 12, and I use port 12 for VLAN, for the native VLAN 1, right? When you read this command, you can see. Okay. So, when you turn on a switch, it doesn't necessarily have any security. So if the administrator doesn't configure the security, it will just show up as, you know, you can just go into different mode by typing in the command. But if you want to enforce login, you can type in a command called login local, and that requires a login for the person who configures it. So some of the things that we need to be mindful of when we are configuring the devices. You are remotely connecting to it, so make sure that your connection is secure. That's the most important. You can also set up port mirroring, so that way you would be able to copy data for monitoring purposes. We talk about this in security all the time, right? I can mirror port 1 traffic to port 10, and whatever happens in port 1, I see in port 10. The only downside is that it's taking up a port, but we would be able to see what's going on. So you need to enable port security. So make sure that you do MAC filter. That means that if your client systems is MAC A, B, C, D, E, F, G, that needs to be tied to a specific port number. If another system connects to it physically, it will not allow that system to connect. So we want to make sure that we do MAC filter, 1 address per port. That's what I emphasize here. And as you go, when you do IT audit, you need to audit your list, right? Your systems, your inventory. There are tools that you can use to do that. Okay. And then login local is here. This is how you set up your login. Now, I talked about not using Telnet last time, right? In the past, they would use Telnet. So if they do 5 login Telnet ports, they can do a BTY04. So if you want to configure your login local, you would do configure terminal line con 0, and then you're going to do a login local to enforce login for that device. All the new appliances now require credentials, so you would need to set that up initially. But in the case that they don't, you can enforce it. Okay, troubleshooting information is right here. So that brings us to 23, which is the end. So the difference between the layer 3 and up switch, which can route, right, and transport and do more, is that it has additional requirement for connectivity. So there's a comparison. If you're doing layer 1 or layer 2, check 1, switching loops. I always start with hardware and move to software. So check cable, check link light, check your port configuration and your switching loop, check your VLAN, check your MTU or MTU for black hole to see if it's pulling all of the things into the, so make sure that you have matching information for MTU. Check power failure and making sure that there's no bad modules. Okay. Now for the layer 3 and up switch, because it's routing, make sure that you check the route table, and you can just do route to be able to pull up route table. And you can do that in user exec mode or show route. Wrong subnet mask, that sometimes can happen. Wrong gateway, sometimes that can happen. Never have a conflict in IP address. If you do, right, like let's say I have a switch having the same IP address with another switch, that's a no-no, right? Conflict is going to create disruption. So check your IP address and then check your DNS. Okay, those are the things that you need to check when you are working with layer 3 switch if something's wrong, right? But look at what the issue is, and then logically work your way through each area to be able to troubleshoot. Any question? Okay, so I'm gonna end the video. We're gonna take attendance and a break. When you do the lab today, you are going to create a login account with Cisco Academy. Use your RCCD account, right? This is a lifetime membership, so you should be able to use it after this class or outside of this class. I can create a course on there, but you can also take learning modules on Cisco Academy, like learn more about packet tracer, learn more about IoT security. There are tons of free courses, and then they also have courses that they charge for. But you can also add appliances to your packet tracer by having certain membership and account. I think you can download some of that either through them or elsewhere. So we are going to use packet tracer for the lab today. It is installed on your computer. And if you use your laptop or your home computer outside of here, make sure that you install the latest packet tracer. You have to log in to download, and you have to log in to use now, right? Packet tracer doesn't allow you to do that. Before long ago, you just need to run the exe and be able to do that. So a lot of people illegally pass packet tracer around, but they require now that you have a free account or you have a Cisco Academy account. Okay, so I will end the video and we'll take attendance.